All right, so let's check out the practice homework for this. And here is number one. So we got x squared. And we're going to take this limit as we go to minus 10. And if you look at the numerator, you can see we can factor that. And we'll have x plus 10, x minus 10, all over x plus 10. And then those x plus 10s will divide out. And so we'll be left with just the x minus 10. And now we can plug the number in. For our answer. Check out the next one here. And so now we have a polynomial that can be factored in the numerator and denominator here. So if we would plug 4 into all this, we would find that this is 0 divided by 0, the indeterminate form. So you can always check that by just plugging the number in. You'll see that it doesn't work. You don't get a number out. And so we got to do something else. And that other thing we're going to do is factor. And so what do we got here? We'd have and then the denominator factors. And then we have those x minus 4s that can divide out. So this is what we're taking the limit of now. And let's try the number again. See what happens. So if we just put the number in there, actually, let me just put the number in there. And we get a number out. And that's our answer. So let's check out the third one here. So looking at this one, we got a polynomial in the numerator that can be factored, but nothing in the denominator to do. So again, if you want to plug 6 into that, you'll see that this is 0 divided by 0, an indeterminate form. And we want to try to get out of that. In this case, we factor. And so we have the x minus 6's that can divide out. And x plus 2 is what we're taking the limit of. So now we'll check the number again, see if it works, and it does. Now when I say it works, that means we're not getting 0 divided by 0. We're getting an actual number out. So here is our infinity limits. So here's a limit going to infinity. We'll check that out. We're going to do this limit here. And remember, this is all about dominant terms when x is going to infinity. So what we're going to do is only look at dominant terms. Now there's only one term in the numerator, that's 4x. So that's going to be the dominant term because it's the only one there. And in the denominator, the dominant term is 4x. So the minus 5 is all constants. All constants are power 0 because minus 5 equals minus 5 times x to the 0, where x to the 0 is 1. So all numbers, all constants are considered power 0. So minus 5 is power 0, but 4x, that's power 1. So that's the dominant term right here, the 4x. And so we get to this result here. And then we see those 4x's can divide out. And so we're taking the limit of 1. And a limit of a constant is always that constant. So looking at the next one, if you notice, these are polynomials of the same power, same degree here. So we have a 7x squared and a 2x squared. And going to infinity. Now remember, when we're going to infinity, we only care about the dominant terms. The dominant terms will describe all this behavior at very large numbers. So the dominant term in the numerator is the 7x squared. And the dominant term in the denominator is the 2x squared. And we can see those x squareds will divide out. And the limit of a constant is always that constant. Number 6. So if you notice this one, the dominant term, the largest dominant term is in the denominator. If you remember what that means from the video, you can predict what this answer will be. So we're just going to look at dominant terms because x is going to infinity. So the dominant term in the numerator and the dominant term in the denominator. And then we can make some simplifications there. Now x is going to infinity. So this is kind of like, so 9 times infinity is still infinity. And any number divided by infinity is always something that's going to 0. So 7 divided by a number that's getting forever and ever larger means this limit is 0. And again, if the overall dominant term is in the denominator, you will always get a limit of 0. So what do we got for number 7? So the dominant term here, the overall largest dominant term in the numerator, we can predict what this will be. So we're just going to look at dominant terms. Get rid of everything else. So in the numerator, that's 8x to the 4th. And in the denominator, 3x cubed. We'll do whatever simplifying we can. So as x goes to infinity, x will go to infinity. So 8/3 here, anything times infinity, well, any number greater than 0 times infinity is always going to be infinity. So as x gets larger and larger, 8/3 means that's just getting even larger. So that is going to infinity. And again, that's something we'd always expect. If the overall dominant term is in the numerator, we expect our limit then to go to infinity. So let's see what the last one here is. And notice for this one, the numerator and denominator have the same power. Or no, they don't. I almost got fooled. Ho ho. MyMathLab being a little bit tricky in this one. So, what's a little bit tricky? Because normally we write polynomials in descending order. So when I wrote 3x squared, I just automatically assumed the next one would be lower, but it's not. They're actually writing this as to the 4th, and there's nothing wrong with that. There's nothing that says polynomials have to be in decreasing order. A lot of people just think it looks nicer that way. It doesn't have to be. So this is actually the dominant term here because it's to the power 4. And here's the dominant term in the denominator. And then we'll do whatever simplifications we can. So again, anything times any number greater than 0 times infinity is going to infinity. So as x goes to infinity, well, x squared is still going to infinity. Infinity times infinity is still going to give you infinity. And then the minus 3/5 times that just means that's going to a minus infinity. And so overall, this is going to a negative infinity. So it's going to infinity in the direction of the negative numbers. And MyMathLab does have an option for minus infinity here, so they are definitely looking for that. And there is practice homework 11.1b.